So Barry, given all this massive expansion around the world that's happening all in the pipeline, what are the limits to growth? I mean, some people have talked about, the finite supplies of these different fertilizers. How do you see that playing out?
Well, if you look at the nitrogen sector, it's primarily about energy, and the main feedstock globally for nitrogen fertilizer production is natural gas. In China, the industry is different, and they use coal. It's not as efficient and a bit more expensive investment. But natural gas is the basis of most fertilizer and nitrogen fertilizer production. Of course, we've seen the shale gas revolution in the US, which means that we're now, after years of rationalization of the US industry because of high costs, you're now seeing interest in new investment in the US. And if forecasts of the availability of shale gas globally are true, and the International Energy Agency is talking about the golden age of gas, this suggests that there's not going to be any shortage of feedstock for nitrogen fertilizer in the foreseeable future. For phosphates and potash, there you're looking at mineral deposits. And potash is very interesting in that good commercial deposits are concentrated in relatively few parts of the world. But the high prices we started to see in 2007, 2008 has led to a lot of looking for new resources. And there's a lot of potash out there. Known potash resources are probably sufficient for at least 1,000 years. And there's really no concern on that. Some of the main focus on resource scarcity has been on phosphate. And there's even a theory of peak phosphate, which is based on the theories of peak oil. And this theory has got a lot of traction initially in academic circles, and there's several groups of academics who are pushing this theory that we are about to run out of phosphate, that even scare stories that we've only got 30 years resources. Well, this is in fact a complete nonsense. Those forecasts were based on out-of-date resources because there hadn't been a lot of development in new phosphates, because it wasn't required for many years. There's even been rationalization in the US in the early 2000s. Nobody had bothered to update resource numbers, but the higher prices that we've seen since the mid-2000s has led to a lot of new resource development. We talked about Saudi Arabia. Vale has developed a new mine in Peru, which the deposit was known about for 30, 40 years. It wasn't economic. And this is the thing about resources, is that in the same way of oil, we've run out of $25 oil, but there's quite a lot of oil when you get to $70, $80 when you look at things like oil sands and shale oils. It's similar with phosphates. There's still a lot of $25 phosphate around. That means resources are economically viable at $20, $25 or so. They're mostly in Morocco. But if you look globally, there are considerable resources that are economically viable at $40, $50, $60. And we're seeing new developments in places like Latin America and Australia, a lot of interest in Africa. And there has been new research to work out exactly how much phosphate there is in the world. And work done by the International Fertilizer Development Center and the US Bureau of Mines. And that suggests that known commercial phosphate resources, so at sort of current price levels of $100 or so, we're looking at 300 years resources. But there is a refined theory of this, which says that saying there's only 3 years assumes constant growth in fertilizer and phosphate demand. But there are a number of factors which suggest longer term that's not going to be the case. And those are more efficient use, and that you get plants to be more efficient in taking up phosphate, so you waste less waste in the production process. But also, and this is a very key, particularly for phosphate, is increased recycling. Now, what happens with fertilizers is that when you apply the fertilizer, the plant grows, the plant takes up a lot of that phosphate. That phosphate then, let's say that's used for animal feed. The phosphate and the other nutrients go into the animal. Part of that then goes into their meat. The rest comes out of the other end as a reusable resource as manure. And basically, manure is a significant form of fertilizers. There's just not enough of it to grow as much as you need. Where fertilizers come out of anything recycling is through us, because we don't recycle our phosphates or nitrogen, and there's a lot of interest in that, because it is a problem. Sewage plants discharging phosphates causes problems with water quality, eutrophication of water. So if we can recycle some of those phosphates, and the place to do it is at sewage processing. There are processes you can produce a product called struvite, but they're expensive and they're quite energy intensive. But going forward, we will start to recycle more of the phosphates that we use, that not so much would be in fact wasted and going into the oceans. And that, if you take that increased recycling, more efficiency, discovery of more resources, we're probably looking at 1,000 years and beyond of resources. So nobody need worry that we're going to run out of phosphate. But it is a theory that does appear to have got traction in the public mind, but it's totally misguided.